Hey, a quick recap of what we learned last week, guys. Basically, before we go into the exercises, guys, basically we learned about the difference between display formula and structural formula, right? A display formula, like the name suggests, is all the bonds displayed together along with all the atoms and molecules and whatnot, right? So usually when they ask you to draw display formula, you have to like write everything down, including either the single bonds or the double bonds. And a structured formula will look something like this. You'll have all the atoms listed out here, guys, like carbon, hydrogen, hydrogen, blah, 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 all these kind of things, right? This is a displayed formula. This is a structured formula, right? Structural formula. After that, we also learned about the understanding of what an isomer is, guys. Is in your exam, this question actually comes up a lot, guys. You have to know that they have the same molecular formula. This is a keyword, by the way. For isomers, they have the same molecular formula, right? Compounds that have the same molecular formula but different structural formulas, guys. Right. So from here you can see that this is butane. The main idea is that it contains 4 carbons, right? And then this is an isomer of butane, right? It also contains 4 carbon, but arranged in a different manner, right? Obviously, their structure is different, right? But the molecular formula is still the same, okay? These are also examples. You can refer to this later on yourself. In terms of the double bonds, guys, depending on the position of your double bond, it could also be a isomer, guys. For example, you will notice that this double bond here is on the first C, and this double bond here is on the second C, guys. If you remember last week also, guys, how come this is the first C and not the fourth C? What did I say again last week? Did I mention this last week? I want to ask you guys one question, guys. Is this the different than this? Are they different? This one and this one, are they different? Why not? Even though it may seem like this is the first C and this is the fourth C, right? They're actually the same thing. They're just a mirror image of each other, guys. So they are not considered isomers, guys. They are essentially the same thing. Because we always take into account the first carbon, and then after that only we start counting. In this case here, this double bond is connected to the first carbon, and this double bond is also connected to the first carbon. They're the same thing. Remember, guys. Okay. Yeah. Then after that, we also learned about the homologous series, guys, which I've mentioned here. We'll be focusing on these 4 first, right? For now, alkane, alkene, alcohol, and carboxylic acid. Alkanes, they are usually saturated. They contain only single bonds, right? Alkenes are unsaturated. They have double bonds, guys. The formula you need to remember as well, the general formula for alkanes is CnH2n plus 2. Right, alkenes is CnH2n. This one is the easiest to remember because you just need to know that the hydrogen is double of the carbon. Alcohol, they have an OH. They have an OH group in it, right? And they'll usually be something methanol, pentanol, hexanol, octanol, or something along the lines, right? And then you'll see that the general formula is going to be this one here. I do want to, however, highlight one thing, guys, for the general formula of carboxylic acid, which I did not mention last week, guys. If you look at the general formula for carboxylic acid, right, you'll see that it's CnH2n plus 1 COOH, right? Let's imagine today, right, if I'm looking for the carboxylic acid with 1 carbon inside, most students, this is what they're going to do. If let's say I'm looking for the carboxylic with one carbon inside, which is obviously methanoic acid, right? Methanoic acid, there's supposed to be only 1 carbon atom inside, right? So what usually the students do is they'll put 1 here and they'll put like C1H2 multiplied by 1 plus 1 and COOH, right? And then at the end of the day, if you put everything together, you'll actually get CH3COOH, which then after that you realize, hey, isn't this isn't methanoic acid the one that only has one carbon inside? Right, and then if you look at this formula here, there's actually two carbons here, which is the problem right now. Why? How come we only put one carbon inside the N, but then we end up with two carbons in the molecular formula? Has anyone learned this in school already? What are we supposed to do with the general formula? Does anyone know? So what I want to say is, right, guys, for carboxylic acid, the N that we put in, right, is always -1. For example, if let's say I'm looking for methanoic acid, which is supposed to be carbon 1, right? Carbon atom 1, right? We actually need to -1 in this scenario, which will actually get C0H2 multiplied by 0 plus 1 COOH, which will end up with HCOOH, guys. This is methanoic acid. We actually need to -1 for it. For example, if we're looking for ethanoic acid, right, which is actually supposed to be 2 carbons, right? We actually need to -1 again, which is supposed to be 2 minus 1. In this scenario, it will be C1H2 multiplied by 1 plus 1, then COOH. And at the end of the day, we'll end up with something like CH3COOH. This one is methanoic acid. Sorry, ethanoic acid. It's ethanoic acid. This one will be ethanoic acid if we're looking for the second carbon one. And of course, if we're looking for the third carbon one, which is propanoic acid, we have to take 3 minus 1 again, which at the end of the day will end up with 2, guys. So you're going to get C2H2 multiplied by 2 plus 1, then COOH. Then at the end of the day, we'll get like C2H5COOH. This is propanoic acid, guys. So for carboxylic acid, you must remember that the N needs to -1. You understand what I'm talking about? Yes. Okay. And then the amide and ester, you can ignore it for now, because it's something that we're learning about. Okay. Then yeah, these are all the general understanding or description of the things, right? Alkanes are unreactive because obviously they have single bonds and they are already separated. Alkenes are generally more reactive because of the double bond and thus because they are unsaturated. Alcohols are usually miscible, which means to say can be dissolved in water. Generally, they have their OH groups in it, and then carboxylic acid is a form of very weak acid that can go through chemical reaction to form ester. Guys, if you recall what I've mentioned last week, how do we form esters again? From carboxylic acids, we need to plus what again? Very good. We need to plus alcohol, guys. If we have carboxylates combining together with alcohols, they'll actually form esters, guys. Yes. Right. Then, yeah. The prefixes are all here. Met, et, prop, good, pen, hex, hep, op, non, and bec. Right. Depending on what you want. Maybe it could be methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, bectane. Usually they don't ask so far. Like the furthest I've seen them ask in a real IGCSE paper is probably up to here. And this is also very rare. Usually they'll ask up to these first 5 here, right? Methane, if it's alkenes, methane, ethene, propene, butene, pentene. If it's alcohol, methanol, ethanol, propanol, butanol, and pentanol. And if it's carboxylic acids, methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and pentanoic acid, and so on. So if you guys have a problem remembering which one is which, you can go for acronyms that I have provided for you. It's just a guided option. You can have your own way to remember it. For me, it's my extremely puzzled brother passed his hemorrhoids onto Nigerian history. Whichever way that you like. I think maybe your school teachers might teach you something different. Maybe your friends might give you some funny ideas as well. It doesn't matter whatever you use, just make sure you use something to remember it, because you will be tested on this. Yes. Yeah, and these are all the general structures. Alkanes, you can refer to them on your own free time. Alkenes, depending on where the double bond is, guys, depending on where the double bond is, the naming will be different as well. As you can see here, build one in means to say it's on the first, the double bond is on the first carbon, and build two in, the double bond is on the second carbon, guys. Remember this, right? This is relatively important. Alcohol also, depending on where the OH group is, you'll be named differently as well. For methanol and ethanol, generally not much things to talk about, but propanol onwards, it could be prop 1 ol, it could be prop 2 nol. Is that prop 3 ol? Why not? Yeah, very good, because if the so-called prop 3 nol is literally the same thing as prop 1 nol, so there's no such thing, right? Build 1 ol, build 2 nol, is that build 3 nol? No, build 3 nol is the same thing as build 2 nol, so no difference, right? No such thing. And carboxylic acid as well. Carboxylic acid, just remember, is the COOH group, guys. As you can tell, right? Just now I've gone through, I went through the general formulas for you guys already. I actually did not notice this until yesterday when I was teaching another student, and I'm like, wait a minute, something ain't right. Then I really questioned myself for a while, and I realized, oh, the N is actually -1 for carboxylic acids. Remember, -1, -1, -1. Okay, you can refer to the display formulas here for you guys to have like a graphical representation of what's going on. Then, yeah, for esters, which we'll learn later on as well, I've mentioned, guys, esters are basically a combination of alcohol and carboxylic acids, guys. We will always name the alcohol first, then the carboxylic acid, but we'll change it up. Instead of ethanol, it will become ethyl. Instead of butanol, it will become butyl. Instead of pentanol, it will become pentyl, right? And then instead of propanoic acid, it will be propanoate. Instead of metanoic acid, it's metanoate, and instead of ethanoic acid, it's ethanoate, guys, right? And you need to know that basically, for ethanol and propanoic acid, when they combine together, they just remove the H2O, guys. You guys remember? Right? Remove the H2O, right? For example, this thing used to have, the alcohol used to have OH here, right? And this thing used to have a OH as well, right? These two were removed, right? Meaning to say, whenever alcohol and carboxylic acids combine together, they'll have a byproduct of water as well, H2O as well, guys. Right? Yes, everyone, please know what I'm talking about, guys. Okay? Yeah, you can go play around with the esters later. Okay, so having said that, let's go through our exercises together, guys. Guys, I want to remind you all that next week is the 5th week, and there will be no class. Wow, I can see some happy faces already. Right, there will be no class because it's the 5th week, and then December onwards, we will most likely convert everything to online. We are going to change the December classes. We'll only have 2 classes on December, guys. Then after that, the next two weeks is usually holiday because the students, they will generally go for their holidays and trips or whatnot. But for December, we'll most likely change the classes to online classes. Then we'll resume physical classes back in January, guys. So for you, I'll probably see you next year if you decide to come. And for everyone else that has been enjoying the online classes, yes, you can continue to enjoy online classes until December is over. Okay, anyways, let's go through the exercises, guys. I've went through these exercises. It's generally quite doable, right? It's most of the things that are from the notes. So let's go through it. Guys, if you have any questions, please stop me, guys. If not, I'm going to assume you understand and we're just going to keep going forward, guys. So first question is, which of the following shows an alkane? Alkane can't be double up of each other, right? All this is double up of each other. So, you know, when I say double up, it's like 2 to 4, 4 to 8, and 5 to 10. All these are considered alkenes, guys. These are all alkenes. So obviously the answer is C. right? Which of the following structures shows a compound that belongs to a different homologous series? Obviously, all these are single bonds, right? And thus they are once again alkanes, and the only one that has a double bond is the alkene. So this is the answer is just C for question number 2. Quite straightforward, quite easy. Question number 3, the diagram shows a structure of ethene. Which of these following compound has a similar chemical properties of ethene? Similar chemical properties means to say they belong to the same homologous series, and once again, it's literally 3 marks here. If you got these 3 wrong, something is wrong with you. The structure of 4 organic compounds are shown, which one does not have the displayed formula of the compound. Displayed formula means to say everything is nicely put outright, everything is literally displayed outwards. The only one that has a structural formula is this one, guys, because they combine everything together, right? Which of the following is not a feature of the homologous series? They have the same functional group. They have the same physical properties, no, but they do have a trend of physical properties that is predictable. They have the same general formula, and obviously they have the same chemical properties. So answer is B. For physical properties, remember, same homologous series, they have a predictable pattern, guys. They definitely do not have the same physical properties. For example, they could have increasing boiling point or decreasing boiling point, and so on and so on and so on. Right. Next page, which of the following structure is named correctly? Propane with a double bond is definitely not it. Ethanol with an OH will most probably be it. Ethene with no double bond is not it. And ethanoic acid, there's 3 C's here, so it's this ethanoic acid. Ethanoic acid is 2 C's over there, guys. So this is definitely not it. So answer is B. Question 1. Organic compounds can have names that have suffixes of N, in, L, or alkanoic acid. Which of these following at least have 1 double bond? Which are the ones that have the double bond, guys? Alkane got double bond? Alkene got double bond? Alcohol got double bond? Ethanol, carboxylic acid got double bond? Yeah, so 2. Easy, straightforward. And then when the number of atoms in the molecule of a hydrocarbon increases, the amount of energy released when it burns increases. So basically the keyword is more number of atoms in more number of atoms in the molecule, then more energy is released when burned, right? So which one has the least energy and which one has the most energy? You'll just have to figure out which one is the longest and which one is the shortest. For example, we have methane here, right? Methane is basically CHHH. Ethene is basically C double bond HHH. And ethane is basically C double or single bond HHHHHH. Right? So which one has the most? I think it's this one already, right? A is the answer, right? Yeah, A is the answer already. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Yeah, A is the answer. Guys, because 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Guys. So more. Yeah, correct. Okay. Then the diagram below represents the molecule of a compound, something. Oh, it's all here. Okay, so there's carbon, hydrogen, oxygen, and carbon. Obviously, this is going to be an alcohol, right? And the only answer is that ethanol, guys, 2 C's. And this question, for some reason, some of you guys were struggling with this. For some reason.
Just called more than D for the team.
Count the symbols. You mean the carbon atom? Yeah, you could literally just count which one has the same amount of carbon because they are looking for isomers, right? Isomers, same molecular formula, different structural formula, right? Yeah, 1, 2, 3, 4, 5 carbon, 1, 2, 3, 4, 5 carbon. Then there's going to be like 12 hydrogen here, and if you count it manually, you'll have 12 hydrogen here. So your answer is C and F. It cannot be any other thing because the only one that comes close is going to be B and donkey. But when I say come close, I mean to say in terms of carbon only. They don't even have the same hydrogen. So yeah, no. Yes. Right. Okay. First three members of homologous series are shown. All of them are basically the. Oh, okay. Why do these molecules represent the same homologous series? They contain carbon and hydrogen atoms. No, they have saturated bonds. No, they have the same functional group. Maybe they will react differently from each other. No. So answer is C. They have the same functional group, but they all have the COH, and COH group. Okay. Next. Which pair of the following shows a homologous series? OH, COH, no. Single bonds and single bonds, maybe. Single bond, double bond, no. Double bond and polymer, no. So only B. Right. Which group of compounds is from a homologous series? OH, OH, OH. Probably this one, right? OH, then all this alkene, sorry, this alkenes, alkanes, and then alcohol, no. This alkane, no. O C double bond, carboxylic acid, alcohol, acid, no. So only this one, because they're all alcohol guys with the OH group. Next, which of the structures are named correctly, guys? Ethane? Definitely not. What's this called again? Yeah, I mean the name of this alkene. Yeah, it's ethene, guys. All right, this one correct? Ethanol? Yes? No? Yes or no? Yes, for sure. This one maybe you don't know, guys, but guys, let me introduce you to this new thing that you probably haven't seen before, guys. Do you know what does the word di mean? Yeah, means to say it's two, guys. Dibromo, right, means to say there's two bromine attached to this ethane, which is actually correct, guys. So the correct one is 1, not 2, and 3. 1, not 2, and 3 is basically not here. Okay. And then the final question before I move on to the paper 4 questions. The diagram below shows a reaction scheme. What are the names of these compounds? You actually don't need to care about the cracking, the steam, and oxygen for now, but you will eventually learn it. I think maybe next chapter or the next one, can't remember. But basically, based on the display formula, you can already tell what's the names. So, starting with you, what's this called? Ethane. So it's either going to be this or this already. A and C for sure. Next, you. What's this called? Ethene. So it's going to be this and this. Doesn't eliminate anything. You. What's this called? Huh? No, very good. So definitely not this one. Right. And then this is the final one with the carboxylic acid in it, which is ethanoic acid. So B lah. No other answer. Okay, ladies and gentlemen, anyone has any questions with the ABC part? Give me a minute, guys. Okay, next, moving on to the paper 4 questions. Alkanes and alkenes are examples of hydrocarbon. I literally said this during last week's class. What does hydrocarbon mean again? Yes. You answer me, what's a hydrocarbon? Very good. Compound that contains only hydrogen, which is in the name, and carbon. Easy. Then after that, you're supposed to give the general formula for a straight chain of alkanes and alkenes, which if you just bother to flip the page, you'll get the answer U. What's the general formula for alkanes? What about alkenes? C2, general formula, oh, I don't want the number. We are supposed to have C what? H. Good. Here, instead of alkenes, what's the general formula? What? Cn H2n. Very good. Literally just flip to the back and you'll find answer. Very straightforward. Okay, then question 1b is a little bit out of place, but it's good practice, right? You're once again asked to calculate the empirical formula given the percentage of the whole compound, right? What do we do again? What's the first thing we do? How do we find the empirical formula? What do we do with the percentages? I'll give you a hint. It has to do with something with the molecular formula. Oh, sorry, molecular mass. What do we do? I don't know. Don't think. What do we do? Don't know.
When you divide each percentage by a value, right? So that they get 4% of carbon, they just divide it by 4 or something.
Then this one. Then this one. Very good. Then you get a number. Then after you get the number, what do you do with the number? Okay, let's divide this first. Everyone tell me what's the answer for this first. 54.54 divided by 12 is... Do you do this, by the way? Do you do this one? The empirical formula? 4.545 55 This one, obviously 9.09. And this one? 2.27, excellent. So after we have these numbers, what do we do?
You divide it all by the lowest number.
Very good. We take it all and we divide it by the smallest number, which in this case is 2.27. Yeah, by 2.27, and then this one divided by 2.27, and we get something. What's that something?
You get the smallest number ratio. Yeah. That's it.
Yeah, what number is this?
Oh,
Somewhere around 2 point something, which is 2, this one?
4.
4 point something, which is 4, and this is obviously 1 lah, right? So right now I know that there's 2 carbons, 4 hydrogens, and 1 oxygen, right? So the empirical formula will be very good. Hey, remember how to do this, guys? This is like quite 3 marks in your exam. You need to remember the steps to find the empirical formula, which comes up quite often, guys. You need to know. Good. Even you didn't do my homework.
I didn't do.
Shut up, lah. You didn't do.
Half of it. Yeah.
Shut up, lah. You left the damn paper in our office. Why? Am I supposed to do your homework for you? Okay, then next, what do we do? Compound X has a relative molecular mass of 88. Deduce the molecular formula of compound X. What do we do? How do we relate this 88 with this thing here right now? Anyone? Guess who am I going to pick next? Okay, I'll give you guys a hint, guys. You're supposed to find the relative molecular mass of the empirical formula first. Everyone find me the relative molecular mass of the empirical formula first and think about how do I use that to find the molecular formula of compound X. Yeah. This thing is 44. And they say compound X has a molecular formula of 88. So what's the formula here right now? What's the formula here in this one? 2C2? No. How much moles are 2? You're trying to say this 2C24H4O, is it? Yeah. Huh? What? You tell me what? What's the molecular formula of compound X given that this thing has a molecular mass of 44? 乘2 So C4? You guys know what I'm talking about? Yes, Aisha. Are you confused? Do you get this 44 or not first? Right, so right now the basic empirical formula is 44. But right now they say compound X actually has a molecular mass of 88. From here to here is a multiple of 2, right? So in reality, my molecular formula of compound X is this thing multiplied by 2. Yeah? So that's why I C4H8O2. You get what I mean? Yes, Michael. Okay, ladies and gentlemen. Moving on to the next question. Propanoic acid is a carboxylic acid with its formula C blah 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 blah. Propanoic acid is the 3rd member of the homologous series of carboxylic acid. Give the name and structural formula of the 4th member of this series. The 4th member is known as you. What's the name of the 4th member? Butanoic what? Even bother attempting the paper. It's literally in the notes. Butanoic acid, yeah. What's the structural formula of butanoic acid? Very good.
Wait, so add only minus one for the acid, but everything's
Yeah, only for the acids, nothing else. And for those who didn't even know, you could have actually referred to the one on top. It's literally given to you already. Okay, next. Members of the homologous series have a very similar chemical properties. State three other characteristics of the homologous series. So we all know that the same homologous series already have the same chemical properties, right? Right now you have to name three others, which I think some of you guys have not seen these kind of questions before. So I'll go ahead and give you guys the three here right now. They're supposed to have the same general formula. They'll have the same functional group, and they will have a predictable physical property. Right. You might need to remember these things, guys. They will ask you in your exam. But for me, I feel that these two are like free marks because everyone knows this, right? The only thing that you kind of need to understand is the predictable physical properties. Right? Yeah. Then just remember these two are at least you can at least write two of these. General formula and same function. Okay. Ladies and gentlemen, any questions? Next. The alcohol forms a homologous series. The first member of methanol and the fourth member is butanol. Give two general characteristics of the homologous series. Once again, you can write down the literal same thing, right? You can either write they're the same functional group, same chemical properties, same general formula, same preparation method, or so on. It's the same. It's literally the same question with the same answer. But this time you can write chemical properties as well. Calculate the mass of 1 mole of C8 alcohol. First and foremost, what's the structural formula of C8 alcohol? What's the general formula of alcohol again? CN. HN plus 1. And OH. Isn't it? And yeah. It's 2n plus 1. Oh shit, no. Where is it? Yeah, it's supposed to be 2n plus 1 now. So from here, if you're looking for C8, you literally put 8 into here, right? And you'll get C8H17OH, right? And right now you want to find the mass of 1 mole of this alcohol. What's the formula that calculates the mass with moles again? Stoichiometry, guys. What's that one formula that involves the moles and the mass? What's the formula, guys? It's literally the most common one. Yeah, what's the formula? N equals to seriously, you tell me what's the answer. Huh? Stoichiometry you haven't done yet? Are you sure? You. What's the formula? I think I've taught you this multiple times on that damn table there. What's the formula? Oh my god. You, tell me. Wow, seriously, no one remember. Come on, Jan. Wow, very good. What a shame that only one person can answer me this. Did you? Sorry, I didn't hear you. But I'll give you the benefit of the doubt. So, what you need to do with this formula, what do you do with this? What is the first thing we do now? Yeah, plus everything together and tell me what's the mass. One more. Hey, do it right now, everyone. Huh? 106? No, wrong.
130.
130 what? Kg or gram? Good. It's 130 grams, guys. How do you have 106?
630.
Oh.
Yeah.
Anyone cannot find 130? Guys, this please remember this formula, guys. It's, I would say 80% is going to come out in your paper 4. 100% is going to come out in your paper 2. Like 100%. And once again, like I always say, same for physics as well, whenever there's calculation questions, you should not lose your marks because the answer is definite and the number is certain. Okay, guys, everyone got 130? Yeah? Next. Give the name of the structural formula of the third member of the series. What's the name and the structural formula of the third series of alcohol? Propanol. What? Say that again? Oh, prop 1 all. Yeah, I mean, it could be anything now, but okay, for what you're saying is prop 1 all, right? Prop 1, oh no, prop 1, prop, no. Yeah, but anyways, you don't have to write this here because they're not very specific unless you're asking for isomers and whatnot lah. But for now, you could just write propanol as your answer. Propan, sorry, it's not prop, it's propan 1 nol, propanol. But it doesn't matter, right? That was the structural formula. Then, yeah. Yay!
Let's do some questions.
So open one hole you can.
Can. Both acceptable. Either you write propanol or propan one or. Okay. Moving on to the next question. This the structural formula of the fifth member pent one null is pentan one null is drawn, blah, 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 blah. Draw the structural formula of an isomer of this alcohol. Good, I want to walk around and see. Hey, everyone draw this for me, show me your answer. Better start thinking now for those who have not done it. What's the difference? This is first and foremost not propanol. I think it's got a big member啦，所以跟你讲这样子，本身是很的年轻人，the structural form of the big member，这种比 big member of alcohol，你刚刚你说 structural，还有种哦，alcohol 哎，你本来打算一的，对吧？Yeah, this one right. Oh, right.
That is incredibly full. What the height is like
It's literally a formulated rule. This thing is no different than this thing inside it. Harmony. Wrong. Right. Right. Wrong. I think right. This is chain at the last C, right? Which is in reality equals this thing and this thing is the same thing. Right now, this and this is the same thing. Okay. Wait, why got double bond one suddenly? Alcohol no double bond, bro. Hey, I'll tell you what. If you truly like this strain, you don't want one and more one, right? Right. If you truly this stuff is like the first carbon has 3H thing, right? It is acceptable. Then after that, you collect it with the carbon which already to hydrogen. Okay, this how to do the heck is able to go. We only based on plan. What is that? Yeah, back in my head, I look at the people all the things, right? Rather originally of this thing. The change that right? It's like, okay, here, you know, something like the third thing back with the third and you get what I mean. It's ongoing. This is really thinking this. This guy is really good. It is also business. You see, this thing, right? What you're trying to do is trying to like make this as a branch, right?
But in the eyes of anyone that are this thing is still considered one. So this is still the same as this. So I think no one can give me an answer. Like what's the answer? It's not again. This is really constructed by isn't it?
Guys, I'll give you a hint, okay, for those who are struggling. For those of you who are struggling, do you know that an isomer is just a different arrangement of the things? But okay, everyone, for those I see a lot of you guys draw this up for some reason. First and foremost, the question asked for structural formula. A lot of you guys drew it like this. Hey, this is literally a displayed formula and this is a structural formula. These two are the same thing. One is displayed, one is structured. So I want to say that these two are the same thing. They are not isomers of each other. In order for you to be an isomer, I just need to have a different arrangement. A different arrangement. So some of you guys, instead of putting the OH here, you put the OH here. Which is also the same thing. It's literally the mirror image of each other. So it's not an isomer. Right? How? What should I do? Guys, I tell you the hint. The hint is you're supposed to draw the OH somewhere else. Somewhere else. Then it'll become an isomer. It'll still have the same molecular formula, but it'll be structured differently. Yeah, if you put it in the middle somewhere, it's literally here or here or here. It's an isomer already, right? Because once again, an isomer, same molecular formula, different arrangement. Draw it right now, guys. This is right. This is right. Good. Bro. And literally just of each other. All it is connected with the first D. All it is connected with the bro. What did you make? Alright, you know what? Bro, this like now this is a ball station, bro. Or behind it. That's a whole the fourth and then we had there. Alright. You draw the structural formula. Like display structure all order. Draw the structural formula. This is now. 我要 structural formula, display formula. This is display, bro. 全部翻出来是不是 display formula 咩？我要 structural formula 来。You was wrong. Okay, good. This is correct. Ooh, perfect. This thing and this thing is the same thing. They are not supposed to each other being because this and this is the thing that
This OH is connected to the other. This OH is also connected to other. They are mutually connected, but distinct. If mirror image distinct. This thing is distinct. This thing is. Okay, now that's after
Give up the thing.
Yeah, it's right. But it's still a little combination. Actually, yeah, this is. Somewhere in the chance about that. Yeah, it's correct. But the need of most of okay. No.
Okay, guys, let me show you the answer. Okay, you could literally drew any one of you could literally drew any one of these answers that you have been correct. Where am I? Where am I? Where am I? Ah,
You see,
look, guys, look here. This is a structural formula, right? Because we don't look at the bonds, we combine them all together nicely, right? Don't rojak halfway, got display, then got structural. Then this one is full display, then this one also some display, some structural. Guys, this is full structural, right? CH3, CH2, CH2, CH, then OH, indicating if I were to draw the display formula for this, it would be like CH3, CH2, CH2, then C, H, OH, then CH3, you know. This is one. The other one, this one is literally moving this thing over to this side. And yeah. Okay, this one here is a branch. It's a branch, okay? So this one will be CH3, CH2, then CH, then CH3, then CH2, then OH. This is a branch of this. Do you guys want me to draw all this out for you guys for reference? No. No. Okay, good, even better. Save my work. Aisha. Get already now, Aisha. Do you understand already now? She's bursting out with tears of joy already. Emerald, 明白吗? Do you know what's going on now? Seriously?
I'll get the food.
Soon? When is that soon? Like a movie theater coming soon? Wait, seriously or not? Wait, I'm a bit sad that most of you guys cannot draw the structural isomer. Except for you, though. Yes, and Mr. Google at the back.
but it's like from a renowned chemistry website, and I still get some.
Yeah, I know, but the answer is still wrong because you rojak it. There's display and structural in it. Okay, no, wait, guys, seriously. Okay, wait, I move on now. We don't have enough time. Okay, we're gonna stop soon already. We'll finish this question and then we'll stop. We'll continue to this next week. Predict the name and product form when pentanol. Oh, you haven't learned this yet. You can skip this. You can skip this also, and you can skip this. You haven't learned all this yet. Skip it all. Okay, last question. Really the last question. Okay. So this question here says that butane is an alkene, alkane following the structural form. This is not a structural formula, this is a display form. The equation for the complete combustion of butane is given. Guys, I want to highlight this one thing. You're going to see this word a lot, guys. Do you know what does complete combustion mean? Very good. So it has sufficient oxygen, and usually the byproduct will be carbon.
Monoxide.
No,
Oh,
dioxide. This is not the same thing. It's like saying you were born single and you were born with twins is the same thing. Right? Carbon dioxide, guys, is usually the byproduct of complete combustion. What about incomplete combustion? What will it produce? Huh? Yes, very good. If you see the word incomplete combustion, instead of carbon dioxide, it will be carbon monoxide, which is usually black in color, guys. You know, sometimes you see a factory, they release all the white smoke, right? Actually, the white smoke is kind of okay because it's carbon dioxide, but obviously it's not because it's greenhouse gas, right? But I tell you, if you see black color smoke coming out from the fire, it's worse because that's carbon monoxide, which actually is worse. Okay. So yeah, if you see this word complete combustion, carbon dioxide. Okay, then after that, they ask you to just insert the missing volumes. If 8 moles of carbon dioxide is 40, how many is 2 and how many is 13, ladies and gentlemen? Mathematics time. Good. And 13 should be? Very good. 65. Right, simple ratio lah. If you can't do this, maths class is on the way. Next, butane reacts with chlorine to form 2 isomers of chlorobutane. Oh, you haven't learned this as well, but it's actually substitution reaction. We'll learn this later on as well. For now, just write it like substitution reaction. Substitution reaction. But basically, for those who don't know what's going on, so like the C, and then H, right? All this was originally H, right? But right now I substitute chlorine in it because I'm adding chlorine in it, right? So instead of it being H here, I'll put a Cl here. And this is what we call substitution method. Then it will become chlorobutane. Explain the term isomer. What's the definition of an isomer again, ladies and gentlemen? Very good. Compound with same molecular formula but different structural formula. Write this down. Yeah. Okay, I'll give you, then after that, the next question asks you to draw two structural formulas of the 2 isobutanes, right? Isomers of butane, right? The first one, I'll give it to you, guys. You tell me how to do the second one. C, then Cl, then all this is H, and H. Draw me the second one, guys. I'll be walking around once again. Oh, God. And then we're done for the day. Yay.
I don't even left my one though.
I'll find out.
Just
Is that a CH? Why?
Just like this. If we just and yeah,
Are you paying attention, Michael? Is that a CH? The one at the bottom right, is that a CH? For you? Yeah.
yeah, yeah.
Yeah.
Oh. It's like a CH.
Once again, it's the same thing, my friend. Yeah. very good. You know why, right? You know why this one was failing, right? Because this one, this C still connected to the C and this CL still connected to the C. It doesn't matter if it's CL or CL, it's still connected to the C, so they're the same thing. But now this one. What's that? That's wrong. My God. You're wrong. Very, very really correct. You land, my friend. Where's the second one? C. And the C there.
Oh, what?
That's
Sorry, it looks like big.
wrong. What? No. So like this is correct actually. This is this. So like the yeah, because it was kind of CL is CL is the same thing. So this is the two parameters. This place is CL. Bro. This place anywhere but like这个是一个好大的环。中国这个 D 呢会抓出来一个 relation， 然后 O 还有 O 的 DH 啊。H 这个 is literally like C1 that or some reason DL, which is not possible. How to put the H， 然后还有抓出两个 C， 然后有抓出两个 H， 然后又抓到 C， 然后有两个 H， 还有 C， 还有 H。So this is oh oh。And okay, for this order, you can relax and you can visit cards. But why is this thing already that here? These are the C8 here. This is C8 right? This is C8 right? Then what is the symbology? Then see how it is C8. And you can have H with the origin without on sleep. So instead of having 3 to mean that having this foundation, then it will become like yes. And who is here? Open it back. You tell me what's wrong. 对，you tell me what's wrong？为什么这个人这个不可以打？You tell me what's wrong? Why this happening? 神佛话刚刚我啊，改了，我自己我也怕。哦，what we doing? Oh, I think I want to do chapter, but half of the class is not in it.
啊，不要上啊，我们谈天哦。